All right, science class, let's look at some questions that are going to help you prepare for the test that's going to cover chapters 1, 2, and 3. And we're just going to walk through these questions together. I encourage you to write down these answers on a piece of paper or in your notebook so that you can look back at these and review before the test. All right, right here, this is all from chapter 1 to start. First question, how does the scientific process start and end? So it starts with curiosity. Remember I said let's stay curious. Let's just pique our curiosity and keep wondering, keep being inquisitive and asking questions. And it ends with discovery. What does that mean? It means our curiosity is going to lead to questions and investigations, and then hopefully we discover something. And often in class I will have you discover and investigate instead of me just giving you the answers. Okay? Science and technology, how are they related? They are interdependent or interrelated. What does that mean? It means that as we discover things in science, that leads to new technology, and then new technology then can help us discover new things in science. So it is kind of a cyclical or circular relationship. One leads to the other, and they keep building on each other. So you can write that in your own words there. The goal of scientific methods. What is the goal of scientific methods? Well, again, it's for discovery and investigation. With any scientific method, and we're going to talk about the scientific method here, the goal really is to increase our awareness, increase knowledge, to continue to discover. Okay? Our world is an amazing place, and so we want to keep learning about it, and that knowledge then will also lead to new technology, and that helps us discover new science and so on. Okay? The steps of the scientific method. So you should know these. Maybe you don't know exactly the words, but you should know the process and understand that we go through this all the time. The first thing you do is you start with your senses and you make observations. So you observe things, you sense things, you begin to ask questions, and from that you form a hypothesis. A hypothesis is just an educated guess based upon what you notice already. Then you've got to test that hypothesis. So we run some experiments. They may be really formal experiments where you collect data. It may just be that you go and look for something that's going to support your idea. All right? So observations, hypothesis, experiments, and then from those experiments, of course, we collect data and information, and we try to answer questions, and we start to then build some conclusion. Okay? That conclusion then is based upon the experiment. If our conclusion or if our experiment doesn't support our hypothesis, remember, we might have to go back and form a new hypothesis and then run the experiment again. Okay? That conclusion may lead then to some type of theory, and if that theory is repeatable and there's a pattern and over time it is substantiated, that may lead to some type of law, okay, which is a very supportable and repeatable idea that is going to be supported by many, many, many years of experiments and collection of data. Main building blocks of all matter, those are atoms. These atoms retain the properties of their element, okay, the element that they're an atom of. Difference between hypothesis, theory, and law, I kind of already discussed that right here. Your hypothesis is just an educated idea or educated guess. This is just based on your observations. A theory then is based on what? Based on your experiment. Experimental conclusion. And then a law is something that is repeatable. It's repeated over and over, and it is substantiated. What does that mean? It means that it is withstood the test of time, and many, many people and scientists kind of running experiments in order to show that it is in fact true. Independent variables, those are the ones that you manipulate. Those are the ones that you control. You control the independent variable. The dependent variable are the ones that are going to respond to what you do. They're the ones that are going to change based upon what you do. And then the controlled variables are the ones that you keep constant. You do not change those. Okay, these are constant. The system of units that scientists use, those are the SI units. That's the international system. We use things like, for mass, grams, for length, meters, for temperature, we use Kelvin. Now, of course, you're familiar with Fahrenheit here in the States, but Kelvin is what we use in science classes. We also use Celsius. Okay. Scientists organize data, so we have to organize. Remember, we did a whole section on this, organizing data, and we often use data tables. And remember, we want to organize it so that we're looking at tables that compare the independent variable, IV, and the dependent variable, dV. Okay? Line graphs, circle graphs, and bar graphs. So a line graph is going to have a series of data points that are going to be showing some type of trend. Circle graphs are showing maybe a portion out of a whole. So maybe you just have, a portion out of a whole. Bar graphs are good for looking at categories. So bar graphs would be good if you're looking at, like, how many different colors in a bag of M&Ms or something like that. All right, so these would be, bar graphs are great for different categories. If you have categories broken up, circle graphs are great for looking at a percentage or a portion of a whole. Line graphs are great for comparing relationships between two things. Is there an upward trend or is there a downward trend? And then data tables, we just mentioned already. That's how we organize the information. Data tables, you would have your headings up here. All right, and you'd be showing your independent variable, your dependent variable, and you'd have a list of numbers there. And often it may not be listed in increasing order, but sometimes it's helpful to do so because then you can see if there is a relationship or not. Okay? So chapter 1 was all about just kind of an introduction to science and some of the basics of the scientific method and data collection. Chapter 2, we talked a lot about properties and substances and mixtures. Okay? So every sample of a given substance has the same properties. So a substance really is going to be something that is kind of a pure substance. So we might think of something like an element or a compound. Element or compound, and we'll talk about that in just a little bit. So same properties. Why? Because the chemical composition is fixed. It doesn't change. So what does that mean? Well, if I look at an element like hydrogen, hydrogen never changes. Its atom is always the same, and it retains the same properties. Or if I look at a compound like water, H2O, H2O is always made up of 2 hydrogens and 1 oxygen, always. So the properties are not going to be changing because the nature of its chemistry, the chemical makeup, the chemical composition is always the same, and therefore it's going to behave the same way all the time. Okay? Same thing here for number 2. Why is the composition of an element fixed? It has only one type of atom. One type of atom. And that atom retains the properties of that element. One atom or a million atoms of a single element are going to have the same properties. Okay? Composition of water. What does this formula tell us right here? It tells us it's made up of H, which is hydrogen, and O, which is oxygen. In what ratio? In a fixed ratio. In a 2-to-1 ratio. Always 2 hydrogens to just 1 oxygen. That's always the ratio in which that compound, that's how they're bonded, that's how they're held together. 2 hydrogens, it kind of looks like this. Here's an oxygen molecule or atom, here's a hydrogen, here's another hydrogen, and they're bonded together always in that ratio. That is a model of a water molecule right there. Now a mixture is a little bit different. A mixture, they are not bonded together. They're not chemically bonded. You can separate a mixture back into the different components. A mixture can vary because the composition, or I should say, let's say, the ratio of the mix can change, can vary. What does that mean? Let's come down here, let's think about just salt water, or no, sugar water. Let's say your lemonade, you're making lemonade, okay? So sugar water. You can change how sweet that lemonade is or how sour it is. So the properties of your lemonade can change. You want it really sweet? Add a lot of sugar. Okay? If you want it sour, sour, little sugar. More lemon. Okay? So how much you add of each of the sugar and the lemon can change. It's not fixed. So a mixture can vary as far as its composition, and therefore the properties change a little bit. Either you can have really sweet lemonade or sour lemonade. Okay? The basis on which mixtures can be classified. Well, we either call them solutions, suspensions, or colloids, and these are based upon the size of the particles in the mixture. Okay? Solutions have tiny particles. You can't even see them. Suspensions have medium size, and colloids have medium size, and suspensions have larger particles. Okay? So solutions would be like salt water. You can't even see the salt. It's dissolved so small. A colloid would be kind of like milk. All right, it's a little cloudy, but it stays kind of floating and mixed throughout the milk. There's water and fat and cream and stuff like that, but it's all mixed, pretty well in there. A suspension would be something like muddy water, and you would see the mud maybe settle to the bottom after a while. You have to shake it up in order to keep it mixed. A suspension, you have to keep shaking it in order to keep it mixed up. A pure substance. Pure substance is either an element or compound where it has a fixed composition. All right? Element or compound that has a fixed composition. You can't alter it. Water, here's your example. Water, I keep going to this, H2O. It's always going to be 2 hydrogens to 1 oxygen. It doesn't matter how much water you have or how little water you have. It's fixed. An element would be just one of the elements from the periodic table. Okay? So carbon is always carbon. Every atom of carbon is going to have the same properties. It's not mixed with anything else. Those are pure substances. I gave you 2 examples there. All right? We kind of already answered this. Element has only one type of atom, and that atom retains the properties of that element. A compound is a bonded unit, okay? 2 or more elements bonded together, held together. We'll talk about how they're held together later on. Okay? Every element has certain properties. Every compound has certain properties. But this compound may have very different properties than the elements from which it is made. For example, water has very different properties than hydrogen and oxygen from which it is composed. Okay? Number 8, what is a mixture? Mixture is just a combination of different components. Not in a fixed ratio. Okay? A homogeneous mixture, that is also called a solution, it is uniform. What does that mean? It is the same all throughout. Same kind of uniform mixture all throughout. An example would be salt water. Okay? Heterogeneous means it's mixture, but it's not uniform. Maybe there's a clump of something over here, or there may be layers, or maybe something settled to the bottom, or maybe something floating on top. Okay? This is not uniform. And this could be like, again, muddy water. You see things floating on top. Maybe there's a chunk of mud in the bottom. Maybe there's a rock in the bottom. Okay? Even milk. Milk is heterogeneous. Even though it says it's homogenized on the carton, it's heterogeneous because you've got tiny little particles of cream and fat that are going to be maybe concentrated in one area more than the other. Number 9, list some examples of physical and chemical properties. Okay, physical properties are those that you can observe or you can test, but they don't change the nature. They don't change the chemical composition of the substance. So those would be like color, texture. Is it rough? Is it smooth? Is it shiny? You can talk about hardness. Is it hard? Is it soft? Is it a powder? You can talk about boiling point, melting point. You can talk about, is it magnetic? Does it conduct electricity? This may not be an exhaustive list. Can you bend it? Remember we said that's malleability. So those are a bunch of physical properties. When you test these properties, you do not change the substance. It's still the same substance before and after you look at the physical change or physical property. Chemical properties, though, how does it react? Okay? Change. When it goes through a chemical change, it goes through a change in the chemical nature. You make something new. Okay? How can we separate mixtures? Well, I'm going to give you 2 ways. Filtration, you separate mixtures based on size of particles. So remember, the solid gets retained or filtered out in the filter paper, and the water and anything dissolved in the water goes through. Okay? This is based on size of particle. That property allows you to filtrate things and separate them. Distillation is based on boiling point. So if you have a mixture of liquids, some boil at a lower temperature than others. So you start to heat up the mixture of liquids. The first liquid boils out, and then the second liquid boils out. So as I was saying, distillation here is looking at boiling points. So things will start to boil off when you reach the boiling point. And as the temperature increases, the next liquid will boil off, and then the next one, and that allows you to separate things based on boiling point. All right, physical change and chemical change, I kind of alluded to this already. A physical change is something where you alter the substance, but you don't change the chemical composition. You rip a piece of paper in half, it's still paper, okay? You boil water, it's still H2O, it's just a gas instead of a liquid. You have not changed the chemical composition, okay? Chemical change, you actually change the chemistry, the chemical composition. In other words, you make a new product, a new substance. So I talked about paper. Ripping paper is just a physical change. But if you burn paper, now it's something totally different. You can't get that paper back easily. That's a chemical change. All right. If you boil water, it goes from liquid to a gas, it's still water. That's physical change. But if you actually pass electricity through water, and it'll turn back into the gases of hydrogen and oxygen. That's a chemical change. You went from water, H2O, back into the elements, hydrogen and oxygen. Okay? Our chemical change occurs, as I mentioned, and you have new substance, new product formed. That chemical change, we can observe and look for evidence of a chemical change. What are some evidences? These aren't guarantees, but just possible evidence, hints that a chemical change has occurred. You might see a color change. You might see or feel heat given off, heat or light released. You might see gas. You might see bubbles produced. Or you might see a solid produced. We call that a precipitate. Okay, precipitate. Those are evidences of a chemical change. All right, chapter 3, we talked all about states of matter, solids, liquids, and gases, and we took a lot of time, we focused on gases as well. So let's look at these. All right, describe the shape and volume of a solid, liquid, and gas. Okay, you need to know that a solid has a definite shape and volume. That means it's not going to change if you just put it into a different container or you put it on the table. It has a definite shape and volume. It's not going to change if you just leave it alone. It's not going to conform to the container that you put it in. A liquid has a definite volume, but it takes on the shape of the container. All right, so a variable volume. You put it in one container, it takes on that shape. You pour it into a different glass, it takes on that shape. But the volume is going to be the same. It doesn't matter what glass you put it in, the volume of the water is going to be the same. A gas, these gas particles are going everywhere, and they just keep expanding and moving outwards until they fill the container. So they will take on the shape of the container, so they have a variable shape. They take on the shape of the container, and they keep filling the container until they hit the inside of the container wall. So they have a variable volume as well. They keep expanding. Okay, you need to know that. Kinetic theory of matter basically says that particles are always in motion. Always in motion. Even solid particles. These solid particles are vibrating. I'll answer that down here. Describe the particle movement of solids. Vibration. Vibrating in fixed location. Okay? Particles are always moving. In liquids, they are rolling. And you can pour them. They are passing by each other. Okay? Passing by each other. They're a little more fluid. Gases, they spread out all over the place. Okay? Kinetic energy, remember, is measuring what? Energy of motion. If things are moving, it has kinetic energy. The particles in a solid, they are packed closely together. Close together. And they are vibrating in a fixed location. Liquids, they are also close together, but they are rolling, passing each other, and tumbling. They're flowing. Okay? Gases, as I mentioned, they're spread out, totally spread out, and keep expanding and bouncing off each other and the walls, and they have a lot of energy. Okay? Pressure produced by a gas in a closed container. Okay, pressure is produced by a gas because of collisions by the gas particles with the inside of the container. So the gas particles are slamming against the inside of the container and creating pressure. There's a force. They bump into it, and there's going to be a buildup of pressure there. Okay? This gas pressure is affected by what? Temperature, volume, and number of particles, as we looked at our demo in our simulation. Okay? Remember, we looked at then the relationship between those four variables: temperature, volume, pressure, and number of particles. How are they related? If one goes up, what happens to the other ones? And we looked at pairs at a time. So I should be able to ask you what happens to one variable when you increase or decrease the other one. So increasing the temperature, what does that do to the pressure? If temperature goes up, pressure goes up inside of the container due to the increased kinetic energy of the gas particles. Likewise, if temperature was to go down, then pressure would go down. This is a direct relationship. Remember, a direct relationship has a relationship where the trend line is moving upwards like that. The graph looks like that. How about pressure and volume? Well, this time, remember our container? If you have a container like this, and I was to take this lid right here, and if I push down on that lid, and if I push this lid down further, and now the container is smaller, the volume is smaller, these particles are going to be closer together, and there's going to be a lot more pressure. They're going to be bouncing into each other with more frequency and hitting the inside of the container wall with more frequency, therefore increasing the pressure. So this one, as volume goes down, pressure goes up. This is indirect or inverse relationship. It's an inverse relationship, or if volume was to go up, pressure would go down. Remember, this graph looks like this. As the volume goes up, the pressure went down. Increasing the number of particles, what does that do to pressure? Well, if I put more and more particles in here, then there are going to be more and more collisions, and it is the collisions that cause the pressure. Therefore, if you take the number of particles, if that goes up, then pressure would go up as well. Likewise, if number of particles goes down, then the pressure would go down. If you take particles out, then the pressure would be reduced. Okay? All right. Then we talked about phase changes. Phase changes are when you're changing something from a solid to a liquid, liquid to a gas, gas back to a liquid, liquid back to a solid, or even solid straight to a gas, gas straight to a solid. Okay? So 6 phase changes. Let's talk about these. And all I'm going to do, let's make a little, maybe I can make a chart down here. Okay? I'll just kind of draw it like this here. All right? If we have a solid, no, you know what? I'm going to do this. Let's make a chart that looks like this. Solid, liquid. There's a similar chart, I think, that we talked about in the book here. If not, you can use this one. All right? If a solid turns into a liquid, that is called melting. If a liquid turns back into a solid, that is freezing. If a liquid turns into a gas, we call that evaporating or vaporizing. All right? If a gas turns back into a liquid, that is condensing or condensation. And a solid can actually turn straight into a gas. That is called sublimation. And a gas can turn back into a solid. That is called deposition. Okay? So you need to know those 6 terms, and you need to know what phase change is happening. Okay? That's answer number 10. The temperature of a substance during a phase change. During a phase change, the temperature remains constant. Even though heat is going into the substance, the heat is being used to help it go through the phase change, to pull particles apart. All right? So the temperature of this is important, temperature of a substance during the phase change, when it actually is going from solid to a liquid, the temperature is not going to change during that time. Once it's all liquid, then the temperature can increase again. All right? But when it is going through a change of phases, the temperature doesn't change because all the heat is being used to pull particles apart and loosen up particles. Okay? That energy, the system changed during, that energy now is being used instead of heating up, instead of increasing the motion of the particles, the energy during the phase change, it is used to pull particles apart. Okay? It's trying to loosen them up, pull them apart. They get more energy and they're starting to pull away from each other. Okay? 13. What happens to the arrangement of water molecules as water melts? As water melts, that means it's going from solid to a liquid. Then the arrangement, it becomes more fluid, less fixed. So solid particles are fixed in place and they're just kind of vibrating. As it begins to melt, they loosen up their grip on each other and they don't have a fixed position anymore and they're able to roll and tumble and pass each other. The opposite is true when it freezes. When it freezes, it becomes less fluid, less movement, more fixed in place. Okay? Okay, evaporation and boiling. Evaporation happens all the time. That can happen at any temperature. Okay? That just means that the higher energy particles are going to turn from a liquid to a gas. So at any temperature, liquid turning into a gas. You know that if you took a glass of water and you set it out on the table, and overnight the water level might go down a little bit. Maybe not a lot, but it might go down a little bit because the higher energy water particles are going to evaporate and turn into a gas. Boiling happens at the boiling point, and that is a result of reaching that boiling point and every particle in that liquid now has the ability to turn into a gas, and that's why you start to see the bubbles, not just the higher energy ones at the top. Okay, that happens at the boiling point. All particles of liquid have enough energy to turn into a gas. Okay? Phase changes, those are only physical changes because the substance is still the same. Okay? So H2O can be a liquid, or you can heat it up, boil it, but when it turns into a gas, it's still H2O. The formula is the same. It's just that the particles have pulled away from each other and have spread out as a gas. Whereas in a liquid, they lose some energy, they have less energy, and they're pulled together and attracted to each other. So it's a physical change because you haven't changed the chemical nature of it. All right? All right, heat of fusion. Okay, the heat of fusion. Fusion, another word for fusion, is melting. Okay, so the heat of fusion is simply how much energy, how much heat is needed to melt something, a certain mass of something. Okay, there's also heat of vaporization. That would simply be the heat that you need to vaporize something, to turn it from a liquid to a gas. Okay, so heat of fusion is to go from solid to a liquid. Heat of vaporization, liquid to a gas. Okay, last one. Phase changes are either exothermic or endothermic. What do we mean by that? Exothermic means that heat is going to be released. Okay, heat is given off during that change. Heat is released. Here, endothermic means heat needs to be absorbed during that process. Okay? So another way to say this is, in order for something to be exothermic, if heat is going to be released, the substance itself is going to cool down. You're cooling down the substance. You're taking heat out of it. Take heat out. All right? Here, put heat in. So let's think about this. Which phase changes do you have to put heat into in order for them to occur? Well, in order for a solid to turn into a liquid, you need to heat it up. So that is melting. Okay? On the other side of that, if you have a liquid turning back into a solid, that is freezing. In order to make something freeze, you have to take heat out of it. Heat has to be released. So a freezer pulls heat out of something, cools it down, and it goes from a liquid to a solid. Okay? For heat to be absorbed, you need to take liquid and turn it into a gas. That is vaporization, right? Vaporizing something. So that's endothermic. But if you want to take that gas and turn it back into a liquid, that's condensation. That's going to require you to take heat out of that gas and cool it down and slow it down, take away some of its energy and have it turn back into a liquid. And then also you can take a solid and have it turn straight into a gas. That is sublimation. That's going to require you to heat up that solid and turn it straight into a gas. That would be like ice sometimes in the winter. If you see a patch of ice, it doesn't warm up. The temperature temperature doesn't get above the freezing point, but sometimes that ice will begin to just sublime and turn into a gas and it disappears. Okay? If you have that gas and you turn it back into a solid, that is called deposition, and that would require you to take heat out of that gas and have it turn right back into a solid where the particles have slowed down and are in a fixed position. Okay? All right. Let me just check here that I got everything. Okay, I think that pretty much covers everything you need for chapters 1, 2, and 3. If you have questions, ask. Ask questions. If you don't understand something, please let me know. I'm happy to help you. You can actually watch this video again or go back to certain points of it if you missed it or are confused, and it'll be helpful for you. Okay? All right, keep up the great work and let me know if I can help in any way.